will be presenting in innovative in material engineering, which is 3D woven fabric. So first we start with the objective. So our main goal is to explore how 3D woven fabric are designed and tested for advanced engineering application. These fabric are different from impact and energy absorption. This one increase weight stretch for stability. Wait. Okay, for fabric specification, this one I will talk more about this one because of this part is very important. Okay, so for composition, 3D angle interlock is very high performance fiber because it has carbon and also aramide for ballistic protection. Okay, so for this one, for yarn density,
and also we got helmet cycling here. Next, our objective for this project.
Our objective of this project, the first one we can learn to provide flexibility for better performance and comfort in items like protective clothing or shoes. So the second one is to maintain a lightweight structure, which is crucial for performance-oriented sports equipment. And last one is to ensure longevity by resisting wear and tear during high-intensity sports activities.
Next, the process flow. We have 5 steps here. Basically, we use TextGen, which is provide 3D picture. The first step is first we need to choose either we want to use angle interlock or orthogonal. Then the second step we fill in the data such as the yarn, yarn spacing, yarn width, and yarn height. And then for orthogonal,
For applications where weight reduction is essential due to their strengthness, such as sports, aerospace. As you guys can see, 3D orthogonal, they have three straight line. Three warp yarn first, warp yarn second, and z-axis line. So, and this orthogonal is suitable for protection things such as bicycle helmets, for the hard part, outer, not the inside one, or the rackets frame that the frames of the
functional of the product, which is angle interlock suits for flexibility products, durability products, and also for angle interlock basically used for protection. Just in case people in the back cannot see. Good morning, I greet to our lecturer, Prof. Faizul, myself, Nur Syafiqah Aziz, and my partner Nabila Hidayah binti Abdullah. We'll be presenting about the 3D woven fabric for engineering application. So later on, we will take a look why 3D woven fabric is useful in engineering application and differentiate the difference between the 3D interlock and 3D orthogonal. I will pass the session to Hidayah. Okay. The objective of our poster and our project is to learn how to use the texture software, and then to identify the differences as Syafiqah said, and to vary 3D woven structures and design for engineering use. So the next is the methods to construct the 3D woven, and we have choose twill 3-1 for angle interlock, for 3D angle interlock, and plane width for 3D orthogonal. Okay, both of the total yarn we use are the same. And other than that, we can relate the engineering application with 3D woven, and at the same time we can study for our examination, okay, during the process. That's all for me.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Daniel Afan. My name is Muhammad Faris.
My name is Muhammad Akil.
So today we will present to you about our model for 3D woven textile. So first, I will tell you about abstract, the short and the simple one, orthogonal, interlock, and layer to layer. So we made 3 models about orthogonal, interlock, and layer to layer of woven 3D fabrics. So in the abstract, you can see that orthogonal structure, warp and weft yarn are perpendicular, providing height strength and stiffness. Meanwhile, interlock structure feature interlocking layers to prevent delamination, while layer-to-layer fabrics align interlaced layer in specific orientation for tailor, stiffness, and stress. So in our project, we have 2 objectives. We have 2 objectives to gain. The first one,
The objective begin from this project is that we can view the structure of the fabric with more clear view and more detail. The one is to determine the mechanical and other properties of materials.
our process flow. First, we choose the structure, which is the angle, interlock, orthogonal, and layer to layer. And after that, we go to TextGen to create the digital 3D model by entering the numbers, which is our yarn for, and then the data for angle interlock. And then after that, we do the cross sections and insert, and then we refer to our lifting plans. And this is our lifting plan. And then after that, we create our physical 3D model for the orthogonal structure. I'm using rope and ice cream sticks to create based on the digital model. So passing to Apan. So for me,
So, Assalamualaikum and a very good morning to all my classmates and Faizul. In this morning, me, Rashafika, and my groupmates Munira will present about our project. The title of 3D woven project using textile. So, our purpose for this project is to explore more about textile for 3D fabric modeling and to understand the application of textile in modeling.
So now I'm going to talk about the model output and comparison for angle interlock. As you can see, mechanical property for angle interlock tend to have strong and durable with high resistance to delamination. What does delamination mean? Delamination means a process of fabric that slowly turn into thin yarn. Then, for the fabric specification, angle interlock tend to have heavier, thicker, and more rigid with higher thread count. Hence, the design for angle interlock, it has a complex weave with interlocking thread, creating a thin and textured surface. For the end use, for angle interlock used in aerospace, ballistic protection, and heavy-duty industrial represented warp above weft, and the red and pink represented by yarn. So, for angle interlock over here, the design interweave warp and weft at specific angle, and it creates a dense and interlock structure. Each layer is connected by binding yarn and enhancing the stability of the fabric. For 3D orthogonal, the warp, weft, and binding yarn are arranged in perpendicular layer. The binding yarn secure the fabric by stitching multiple layers together, maintaining a consistent structure across all directions.
Good morning to everyone. My name is Ivanila and my friend is Nurin Hasana. Today we will present our 3D woven fabric structure, which is 3D angle interlock and orthogonal. Our main objective is to create complex structure of 3D woven fabric with 4 layers using textile software, and to identify comparison between two different types of 3D woven fabric. In mechanical properties, assess the tensile stress ability, flexibility, resistant to wear and tear for each fabric type.
As you can see, this is a detail for angle interlock and orthogonal structures. So, angle interlock more complicated and have a different pattern. For orthogonal, have a perpendicular structure, and as you can see, also this have a repeated structure like a penguin. So, for angle interlock, have use 90 degree to below, but 45 degree incline. And then, but for orthogonal, have 90 degree like this. So this looks like the penguin.
We saw that we learned how to produce to make the design using the textile software. We enhance our skills to create other than 4 layers. We also learn to how to create binder 1/2. I'm not only use 1/1 binder like that.
So we also learn how to solve the problem because we use the sellotape and make it harder to compile this structure because we live in college, so don't have hot glue gun. We can use the hot glue gun.
Next, we saw that angle interlock have a good shareability because it can move into the shape.
And orthogonal is more strength if we put more web and warp. So this will be used only 20 web but 5 warp.
Okay, all the answer